All right, started, I think. Okay. 2 minutes and 30 seconds. All right, let's go over the agenda and see what we have for today. Ooh, I'm getting, oh, can't hear me right now. Okay. Please. So how's everybody's day been going? How's your week been going?
Mood. I'm okay. Just hanging in there. How about you, my dude?
Yeah, not bad. Almost missed the meeting I had this morning. I have to submit a petition for my one quiz because I submitted the quiz on time and I didn't realize you had to go on Quirkit. Like I submitted the quiz on CrowdMark and it said like submit your MATLAB file and your Excel file. I tried to submit it and CrowdMark was like no. And then later in the day, I go on Quirkit and there's an assignment separately to submit those files. So that was late. And I had to submit a petition.
A real one would just take the L, you know? Put yourself on hard mode.
It's 14%, but okay. Yeah, okay, so quick updates, actually. I want to take you guys back to this presentation. Let me just pull it up. And if it loads, it loads. I'm going to share my screen. So I want to draw your attention back to this slide over here and just keeping in mind what our goals are and what the timeline is of, you know, what we should be doing. And, you know, again, if you have any questions, you want to have a look at this presentation, I think it's up. If it's not, I will add it. If you can't find it, let me know. I will give it to you. I will like put it up. Yeah, so we're coming into October right now. It's October 4th. So everything in the September section should be done by now. Don't think, yeah, like you should be done. If you haven't yet, you're gonna have to talk to me and we're gonna have to get that sorted out because we're gonna start moving to October. And maybe October doesn't really, it sounds like, oh, we're just continuing the design phase, but by November, we need to be able to start testing. And how can you test something you haven't built yet? So we are going to start testing and building in November. And because a lot of the items have a lead time, like a lot of the components we source have a lead time of like 30 days. We want to be able to test by November. That means we have to buy them in October, you know. So all the part sourcing kind of tasks should be done by now. Charging system, maybe not so much. But the rest of the team should have like your parts sourced already, like we already have it, or you should have the part sourcing plans that I've given you should be like filled out. And you know we should have like a good number of parts to choose from, and then we'll just choose like the best one based on whatever parameters that I had you note down. Any questions on this one? I'm going to take that as a no. Okay, yeah, so I guess we'll hear from the inverter control systems team real quick about what you guys have been doing. Oh yeah, and I said this earlier in the day, like earlier in the meeting, for all the new members, like I know I put you into sub teams with someone who's been here for a while already. You don't have to let them just do the talking. Like feel free to talk about it. Like I've seen some of the work you've been doing and it's good. And I want to hear from you like you know, what you did, what your experience was, and what you found out. So I guess Carter K, you're the only one here who's from the inverter controls team.
Right, yeah. I mean, it's only me and Jung. Well, I talked to Jung privately, and he was telling me that like for now, like, cause we just discussed and went over the pre-chart circuit, and he told me to calculate the resistor values that we'll need according to our battery. So I'm going to get back to him with the values that he got and discuss, because like I'm not sure if like the values I calculated are right or the way that I'm doing it is right, because I'm new to this. So I'm gonna get back to him on that soon. Also, he said he sent me a few links prior to go over to find the parts that we need to start building the PCB design board. Because overall the investigation part is done, like we know what to build. So he sent me the links and we're just researching the parts that we'll need to build the PCB design board. And like he said that he might like once we find the parts, he might send it to, I'm not sure which sub team he said, but he's gonna send it to a specific sub team because they're also ordering soon. And that's basically what we've been doing.
Oh yeah, electronics.
Right, yeah, it was electronics. Sorry, forgot about.
Carter K, if you want to learn PCB design, I think it'd be pretty useful. I don't know if you're.
Yes, I am actually going to like what do you call it? Junks, you actually offered it to like get it like pre-built or like doing something like that, but I actually offered him that like we make it ourselves because that's kind of cool for me. So I told him that like, oh no, I'd rather make it myself, and then he's like, okay, that's fine, because like it's not that expensive anyways. So.
Because we have all the parts for it, but it, you know, you still need to design a PCB and make sure like everything's connected well and.
Right. No, like I'm more than willing to work on that with him.
Awesome.
Right.
You guys will go to the low voltage power system, the power distribution system, and that is Jasmine and Shash.
I haven't gotten a chance to do much this week because I was busy moving from Taiwan to Canada. So it's like what I said last week.
I finished updating the LV power requirements, and then based on our previous conversation, I know that we're supposed to start using AutoCAD, which I'm like not familiar with at all. So I've only watched like a couple tutorials, and that's it.
Okay, yeah, so you probably won't be using AutoCAD. You'll probably be using SolidWorks, and that's okay because I put you in a team with Jasmine, who's really good at SolidWorks. So I put you guys in teams where you're going to be able to work with people who have complementary skill sets that you do, and so you guys can work, like learn from each other and reach out. So that is, again, you guys will going to be doing more CAD work, and we want to continue to do that throughout this next month. I want to get like all the things CADed, everything in our sub team CADed. Like, all right, and also make sure that But I think and the wiring diagram. How's the wiring diagram going? Like the circuit diagram.
I haven't really began that because I'm a little unsure about like for components with more than one unit, are they all going to be in parallel as well? Like there's a few details that I'm not so sure about.
What do you mean more than one unit?
So like for example, if there's a temperature sensor, if you're using 4 different temperature sensors, right? Are they all parallel to each other or?
Yeah. Okay. Okay, we'll talk about this later. That's why we have a minute meeting after. All right.
Okay.
Also, okay, I want to make it really clear here. If you're not sure about something, you're confused, don't just sit there and just let that problem sit. Talk to me. Let me know you're stuck on this. Like set up a meeting or something. If like I explained it to you and you still don't understand and it still doesn't make sense, bring it up or ask someone else in the team too. Like you can put it in the general chat. Tell your problem in the general, like our energy systems chat. Like feel free to do that. So now the low voltage battery system team. That's Mayank and Harsh.
Yeah, we haven't really done much since last week either, so we don't really have any updates, but we do know what we need to do next in our next steps, so uh, we'll get that done this week.
Well,
Yeah.
what were your next steps?
So it was adding the all of the other components to the circuit diagram that I showed last week, which is like when we need to add the BMS, the other the sensors and everything, and then we'll start CADing after that.
Awesome. Awesome. And do you think you'll be on track to finish those CAD models by the end of the month?
Yeah, I think so. We should be.
Because we will also kind of need to do some like more wiring on you guys, but that's good.
Yep.
So now I guess we'll hear from the charging team.
Hello. Yeah, so this week we did more research into all of our reference designs. I looked into the laptop rack charging that Kiki mentioned in our last meeting. I couldn't find much information on that. But I also looked into the setup you sent in the chat yesterday. The ISDQ charger looks good. Like I read the specs in the manual. It looks like something that we can use. I couldn't find a power supply unit that fits your description though. It's either at those specs is either more expensive or like power supply units around like $50. Like they don't usually have the voltage and the power that you outlined. So I'm wondering where you got those numbers and if it's used or like new, brand new.
They're used, and like you'd have to go on like eBay. I don't think you'd be able to find it on Amazon.
Yeah, so, I looked on eBay too, but there weren't that many options. But yeah, I'll look more into it. Yeah, it'll be great if you have a link that I can check too.
Yeah, I'll send you a couple. I'll send you a couple that I find.
Okay, sounds good. Yeah, so that's pretty much what we have for this week. Because last week, I don't know if you saw in the Google Drive, I found a lot of documents. But last week I didn't have time to read over them all. So I was able to read some of those links this week. So yeah, that's all there is, the update from us for this week.
Yeah, sounds good. Also, like if you guys can like fill in your updates into the OneNote too. Like I'm trying to write down as much as I can, but I'm not able to pick up on everything. Okay, so also just a quick gauge, like how many of you here know how to CAD? One, two. All right, awesome. How many of you are here want to learn how to CAD? One, two. Okay, cool. So we need to be able to CAD like a lot of the stuff that we're doing because we need to be able to fit it into the pod. That's going to be hard if we don't. Yeah, exactly. So that's the reason why we want to get all the stuff CADed. And for some things, we need 3D printed enclosures and mounts. But I think you will have access to. We are going to have like a day where everybody gets to learn how to CAD. And if anyone's interested in PCB design, I think the low voltage power distribution team might have to And charging team, any of you guys want to learn how to do PCB design? Two. Okay. 3. Yeah. We might also set up a session kind of like that for for all of our members to learn how to do PCB design from like someone who knows how to do it really well. If any of you know Puneet, it might be led by him or it might be led by someone else. June has a lot of experience with PCB design. If you're interested in it right now, I recommend you to check out like Easy EDA or Eagle is probably where we're going to be using. It's the software we're going to be using for it. And you can like go on YouTube and find tutorials on it right now if you think that's going to be something that's useful down the line for you guys. But otherwise, that's good. Oh, I guess I'll give some updates for the high voltage battery system. So we've already procured some of the parts, actually. We've gotten, submitted SIPSIF, that's what we did last week, to get funding. And so we now have a good idea of what the parts we're going to need are. And we're going to start ordering those actually by tomorrow. I'm going to order a bunch of parts to start testing for the high voltage system. So like a BMS, I think I'm going to order that ISDT balance charger. And then a few other things. We already have the Arduinos. We already have some resistors, might need to get more. To get those things together, and then some connectors. And we hopefully, they have a lead time about like total, like the longest time would be like 30 days. So about a month from now, we'll be able to start testing. But we need access to a lab. So Asir, I know you worked in the energy systems lab last year.
Yeah, what up?
You think you could reach out and ask them if we could use their lab to start testing our batteries?
I doubt it, but like I can ask around.
Yeah, like I mean, if they say no, that's okay. But you just have like the closest connection, so if you don't mind me asking you to reach out to them.
Yeah.
But yeah, otherwise, good meeting, everyone. And if you could just like go on the OneNote and fill out your meeting updates, that would be great. I guess the low voltage power distribution team, you can stay back. You're free to go.
All right, bye guys.
Bye.
Okay, I think Ryan wants to stay on for the conversation. So what was the problem with the thing? What are you confused about? I guess let's pull up a whiteboard. Can I not have a whiteboard? Oh, here we go. Okay, yeah.
Okay.
Yeah, go ahead, sorry.
It'll be good if I can get a bit more information about the circuit diagram thing, because firstly, I don't know which software we're using to design the diagram. Like, is it Simulink or?
Oh, I just draw them by hand.
Oh, okay.
It does.
And then,
for now at least, it doesn't really matter.
and then another thing is like, if let's say we're using 4 of the same component, right? Would they all be in parallel to each other as well?
Yeah. So each one of those components would like say run at 5 volts, right? Let's
Yeah.
just. So
For example.
I'm connecting them onto the 5-volt power supply. If I connected 2 of them in series, they would both be taken 2.5 volts, which doesn't work anymore because they run at 5 volts. So
Right.
everything would be connected in parallel to the rail that it's connected to. So I have we got this 24. Let's say this is positive and this is the 24. This is the negative. So this is essentially your ground. And then I'm going to connect it to this say I have connected it to say this is a 12 volt buck converter. Right?
Okay.
And then it's on this end that comes out 12 volts. So if I had some sensors, like the only way for my components to get 12 volts is if they are all placed in parallel. That makes sense.
Yeah. But then like what would be the point of putting like the same components in parallel to each other? Wouldn't it all record the same information?
As in they're in parallel in terms of the circuit diagram, but they're probably going to be put in different locations.
Oh, okay.
Like these wires. So that's why I drew it like the block diagram. So kind of like what your PCB would look like would be this thing. Here is like your battery, right? Here is your say this is one converter, 12 volt buck converter. So then, like, say this is a PCB with wires, and then you got like connectors here, and then each of these connectors has like 2 wires that comes out, which would be the positive and the negative, of course. And then it can like go all the way to like over here on this side of the pod, and be like one temperature sensor. And you have another connector that goes here on this side of the pod. That has another temperature sensor.
Oh, okay, that makes sense. So the
Yeah.
sensors are all connected to like different parts, but then it's powered by the same rail.
Yeah, exactly. Those
Oh, okay.
in different locations. Yeah.
Okay, that makes so much more sense. I thought it would be so redundant, like it
Yeah.
didn't make sense.
Like those sensors aren't going to be like quite literally, but we're just working on the circuit diagrams in terms of the electron path and everything. That's how it looks like.
Okay, so that means since everything is like parallel to each other, I'm pretty sure my calculations should be right. I'll still like draw it out and try and just to check, but
Yeah.
I'm pretty sure it should be okay.
And actually, you can like think about this diagram the same way for the, and Jasmine, I want you to be able to know these calculations too, because it's something that's like, that like, not that I don't trust your calculations, Shash. It's like, it's better if 2 people do it and you can double check.
Yeah, for sure.
Yeah, I'll do the calculations too.
Like, this can also be, what do you call it? 12 volt buck converter. And this is a 24 volt. So your buck converters are also in parallel to each other. And this is a 5 volt buck converter. And maybe I didn't make it clear. Why do you guys understand why 24 volts we need a boost buck converter, but 12 and 5 volts we only need a buck converter?
Isn't it because like the I say it because like the is it the current or like the voltage input is already higher than like 12 and 5. So you're just bucking it.
Mhm.
And you don't need to boost it to 12 and 5.
Yes. And then the reason why we need it for 24 is actually is because so you guys know that the battery, the voltage is never going to be constant. So if I discharge the battery, it follows this curve. This milliamps hours, and this would be this is left inside the battery. This would be 0, and this would be 3600, for example. This is a very, very big battery, and this is the voltage as it's being discharged. So say it's down here is 2.5, and this is volts. And over here it's 4.2. So it kind of follows this kind of kind of shape, where it tapers off really sharply there. So what that happens is that it translates to, if we combine them in series and parallel, the same thing happens.
Oops, sorry.
Oh, how did you move that?
I don't know. How do I undo it?
I don't even know how I didn't know you could move stuff.
Yeah, me too. I was just trying to move the screen. Sorry.
Oh wait, I figured out how to do it. So yeah, can our battery is and you guys need to know how to do these calculations too. Our battery is 6s2p. So what do you think that means now?
6 in series, and then those series are in 2 different parallels, right? Something like that.
Yeah. So actually, what I like to generate from here is that you'll get 3 numbers. You get V for any battery. You'll have V max when it's full, V nom, which is nominal, and then in this case, it's for one cell, it's usually 3.6, and then V min, which is the lowest. So that would be 2.5, and this is 4.28. This is 4.2. Yeah. So for 6S battery, 6S2P, what do you think it's going to be?
It should be 6 times V max, right?
Maybe. Just try it out. See what happens.
Wait, no, it's. I remember doing the calculation for this earlier, but I don't really remember. Is it 25.2 for V max?
Yeah. That's
Okay.
right. And
What was that?
yeah, that's right.
Okay.
So calculate the rest, and you'll notice something there.
21.6 for V nom and 15 for V min.
Right. So notice that the max and the min, it goes from 25 up here at the top, 25 volts to 15 volts as the battery discharges. That means that my boost buck converter on 24 volts, it's going to be boosting for the first volt, and then it's going to be bucking for the first volt and then boosting for the rest of it, right? But this
Yeah.
V, So this is the lowest the battery is going to go. It's still higher than 12 volts and 5 volts. So it's never going to go below 12 volts. It's never going to go below 5 volts. So I'm never going to need to buck to 12 volts. I'm never need to buck to 5 volts. So I only need buck converters. I mean, I never need to boost to 12, and I never need to boost to 5 because the battery never goes that low. So I only need boost converters there. I mean, buck converters. Sorry. Does that make sense?
Yeah.
Yeah.
Okay. Yeah. And so, are you guys clear about so your wiring diagrams maybe should also include connectors, enough connectors for each one of them, and then we can start to choose connectors that's more of like a mechanical side of things, where we want to pick a connector that's like not too big and not too small. Maybe it's like one that we can make sure they can't put it in reversibly, you know, like they don't mess up the polarity of the wires, and a bunch of other things.
Okay.
All right. Yeah, good meeting. I understand, Jasmine, you can maybe some stuff, but like the time zone is weird for you.
Sorry, I
So-
can't hear you.
Oh, Jasmine, I understand. Okay, I was saying I understand you guys been really busy and like the time zone's kind of weird, and I really appreciate that you guys have been doing this. And I want to see a CAD model of these converters that you sourced
Okay.
together, with maybe with the wires on a little PCB. But before you can do that, you have to first figure out what your wiring diagram is going to look like. So I don't know if I've said this before, but whenever I have my ideas, I'm trying to like do something, I always just draw it out first. I'll teach you how to use a CAD software somewhere this week. Well, not CAD it's CAD software for wiring and to design PCBs to make some diagrams. It's really nice.
Is there any like tutorial, anything that I need to do, or will we be covering SolidWorks later on?
I honestly don't know how to CAD, but
I'm not great at it, but I know how to CAD a bit. Yeah.
We're gonna have like a CAD session at some point. Don't know when. We're still working on that for like all the members to like learn how to CAD. It will be like a lecture of like, you know, there'll be like 40 of us learning how to CAD from one guy. But right now, leverage the fact that your teammate knows how to CAD and can teach you the basics.
Yay. The basics, just the basics.
Yeah, you can like search up on like YouTube if you want to find some useful videos. There's also Solid Professor. I don't know if I've given you the login. We have if you go on design.utht.ca, we have access to this thing called Solid Professor. I don't remember the login. I think Jasmine has it.
I don't think I have the SolidWorks one. I have the Answers hub thing.
Okay, yeah, I'll get access. I'll find like what the login is to Solid Professor and give that to you. It's like Solid Professor is a really good tool to learn SolidWorks, but it's like videos and stuff, but it's really like long, if that makes sense. I think if you could kind of like make assemblies, which is mostly what we're doing.
We're just making assemblies?
For the most part. I don't think you're CADing anything. Like maybe you might make a mock-up of what the PCB is because that's going to be variable size, but
okay. If it's just assembly, then it shouldn't be too hard.
Yeah. And I'd like you to teach Shash, just like
Yeah.
I'll be learning some stuff from Shash.
Okay.
Thanks, Jasmine.
No problem. I'll try to be useful.
Yeah, so maybe by next week we can kind of have a quick mock-up. You could even just do it with boxes and just do drawings, but if you can show that at the meeting and or that'd be great.
Okay.
Wait, Kiki, when you say boxes, do you just mean like on Paint, or do you mean like CAD, like on CAD?
If that's where you have to start, then go for it. Like literally most of what I start is like of my designs, it's like I just draw boxes and like give them labels, and then I'll slowly get the meaning. I'll redraw them in other ways, and until you get to those really nice diagrams. I don't know if I've shown you, but the wiring diagrams, that took a while. Like I drew the same thing many different times in many different ways. And you just keep drawing it until like you keep redrawing it until you get the idea across of like what you're trying to do.
Mm-hmm.
And or like to a point where like you can understand what you're doing and then move it to CAD.
Okay.
But don't just try and dive into CAD without like even knowing what the thing should look like, right? You got to have a good idea first.
Wait, so we're CADing the parts, or are we CADing the wire diagram thing?
So the wiring diagram, there's like a software to do that.
Okay.
Worry about that for now. But you're going to be CADing like the parts and where they fit on the board, and then maybe the wires between them, right? Because and that wiring between them should look like what the wiring diagram is, if that makes sense.
Okay.
Like these are like these black lines over here. This is like traces on a PCB, maybe, or it's wires, and then here would be these XT60 connectors or XT30. There would be some sort of connector. Think about like a USB port. So you would have to make a wiring diagram before you can make this, because this would have to mimic the wiring diagram, but it would be in 3D and actual parts.
Mm-hmm.
Yeah.
Wait, you cut out a bit.
Oh, sorry. So you're gonna have to make this in
Wait, are you pointing something? Because I can't see it.
Oh, you see my mouse?
No.
Oh, you guys don't see the whiteboard the way I do. Okay, go to the box that I made with the battery going into the 12-volt buck converter, and just zoom in on that.
Okay.
So okay, I guess that's sorry, I didn't realize that. But the if you can like zoom out, maybe you'll see what I've been drawing. But if you zoom into just this section for now, those black lines that go to the red boxes, those are like traces on a PCB, or they're going to be wires between stuff if the PCB isn't thick enough. And then the red boxes would be connectors. Like think about like a USB port, for example. So, and then those wires we would just plug in all the sensor cables into. So say you needed to swap out the sensor because it got damaged, or whatever, you can just plug it in, and it's all going to be the same port, right? It's all going to be the same type. So it's like universal. Like if you plug in anything into any of these, they're going to get 12 volts.
Yeah.
Okay.
And like, so before you can even CAD this like assembly with the wires and everything, you need to know what the circuit diagram is going to look like, just the basic circuit diagram, right? Because the circuit diagram is just a simple representation of what this circuit looks like.
Mm-hmm.
And then from that circuit diagram, you can move to doing this. But before you even do a circuit diagram, I recommend doing block diagrams, which is like what I did here, where you just kind of show the path of flow of power, of energy, and what it's converted into. It's almost like a process diagram, where a PNID, where it's like, it's just boxes, and you just give them labels and meanings until you eventually get somewhere. Like this would be the first iteration where it's just block diagrams, and then this is where you start to really flesh things out. And then like of the 12 buck converters, 24-volt, 5-volt. Okay. Yeah, I think that's about it for today. Good meeting, and I hope to see this assembly by or like a block circuit diagrams, block diagrams, just something to show for next week.
Okay.
All right.
Okay.
Bye.
Bye-bye.
Bye, you guys.